the policy for forwarding traffic from the path that is, for example, desirable for us. You know, here we have EIGRP. I'm not going to, for example, disable or shut down the EIGRP. EIGRP should work, and we are using EIGRP. For all of traffic, we are using EIGRP, but for some traffic, we want to forward traffic from other paths. For example, I want to forward traffic of voice, okay, from this path. Look at here. Actually, here I'm not going to disable EIGRP. EIGRP is working like before, but we are forwarding the traffic of voice, only voice, for example, in this scenario, from this path, okay? Don't forget, we are selecting, we are classifying some packets and using the policy for forwarding those packets. But for other packets, IGP or BGP or for example, static routing is working. Actually, here we don't have any work with the EIGRP. EIGRP is working like before. We are configuring policy for dividing some other type of traffic, and after that we can forward them from other paths. Now the question is how we can identify the traffic that we want. Here you have two options, okay? The first option is using the ACL. Look at here. For classification of the packets, I'm going to use the ACL, or access control list. You have learned about the access control list. For example, in the extended access control list, you have control over the source IP, over the destination IP, over the protocol, okay, and also the source port, and after that destination port. Don't forget, here we are not using ACL for filtering. We are using ACL for classification, not classification of routing update, classification of the user data. Also, the next classifier is the length of the packets. I will show you both of these methods. First, I'm going to show you how you can use ACL for classifying the packets, and after that we should forward those packets from other paths. Let me to show you here. In the router 1, I want to configure policy. Why we are configuring policy on the router 1? Because in router 1 we want to forward traffic from other paths. Actually, and now we are working on this router, on the router 1, and I want to configure one policy on this interface. Let me to show you why. Because when traffic is entering from this interface, I want to divide them. First, we should classify the traffics. Some of them should go from other places. Don't forget that when we are talking about the policy is working first. If the traffic doesn't match with the policy is going to the normal routing table. Let me to show you here one simple diagram. Here, this is the traffic, okay, or data, user data. The traffic is receiving by the policy first, okay. The rule is that first we should give the traffic to the policy. This is the policy, okay. After that, if policy match, means here we have a rule about for this traffic, we can say here, yes, policy is matching. We should forward the traffic with the PBR from the path that we want. For example, other paths in compare with the routing table. But if the policy, okay, doesn't match, we don't drop the traffic. We are giving the traffic to the routing table like normal behavior, okay. And in the routing table, if we have paths, okay, let me to write here in the routing table, if we have paths, we are forwarding the traffic with normal forwarding. Let me to show you. This is the normal behavior, normal, okay, forwarding. And if we don't pass, you know that if we don't pass in the routing table for one destination IP, okay, we should drop the traffic like the normal behavior. Here we don't have passed, because of that we should drop the traffic. Actually, here the only extra step is that first we are verifying the policy. If the policy match, okay, we are forwarding the traffic according to the rules that we have in the policy. But if the traffic doesn't match, we should give the traffic to the routing table. And in the routing table, if we have for example, one record for this traffic, we are using the routing table for normal forwarding. And if we don't have pass, okay, in the routing table, we should drop the traffic. Now the question is that how we can configure the policy. It is so easy. Okay, we are configuring one roadmap. Actually, we can say the policy is a roadmap. In this roadmap, we are using ACL, or the length here, first ACL, for identifying the traffic. Actually, here we are using ACL, and after that we can configure from which path we want to send traffic to the for example, router 3. Let me to show you. It is so easy configuration of the policy. In the router 1, assume that we want to select the voice traffic. If you want, you can use ACL, and also if you want, you can use the length, but first let me to use the ACL. For VoIP traffic, we can use for example the application, means TCP, UDP, the specific port, but it is easier for us now that we are using the IP address of the phone 1. Actually, I want to configure if traffic is received from a specific source, this is matching with the policy. It means now we are working on the source IP. Okay, you know that by default when we are forwarding traffic, we don't for example verify, we don't need to compare the source IP. Actually, we are working only on the destination IP. Let me to configure. This is our access list, okay, or let me to configure one extended access list, IP access list extended, for example A. Here we are configuring this command permit IP, okay, from the host of the 10.1.0.20, means the phone 1, to the destination of the host 10.4.0.20. okay, this is our ACL, and then we should configure one roadmap, for example my policy, this is the name of roadmap, and then permit 10 match IP address, then A, means if the roadmap, okay, my policy says that in the sequence 10 we have permit action, and the match condition is the traffic should be matched with the ACL A. Okay, and after that, if traffic match with the ACL A, here you can configure two rules. The first method is configuring set interface. For example, set interface, look at here, you know that when we are configuring the static routing, we can configure outgoing interface, or we can configure next hop IP address. Here again we have two options. We can configure set interface serial 11, this is the first method, or if you want, you can configure set IP next hop, the next hop that you want, for example 10.1.3.3. If one of them can be used, it's better, and it is recommended to using the next hop. You know that by in most cases when we are configuring a static routing, also we should configure the static routing with the next hop, not with the outgoing interface, but both of them are possible in their policy configuration. This is our policy roadmap. My policy permit 10. Now if traffic is receiving is inputting to the interface of router 1 and match with the ACLA, forward the traffic to the 10.1.3.3 or from the interface serial 11. Also, we should apply this policy to this interface. Okay, for applying the policy to the interface, we are using this command interface. Assume that the interface that we are applying the policy is fast Ethernet 00. Here we should use IP policy roadmap, then the name of roadmap name is my policy. Here we don't have the direction, for example input or output, because only we are working on the input traffic. When traffic is inputting to the fast Ethernet 00, we should apply this policy. Let me to show you one simple scenario. After that you can easily understand the for example policy based routing, and after that first let me to configure with ACL. After that we will configure the policy with the length. Now the first scenario in the PBR part of our class is related to the policy based configuration with access control list. Look at this scenario. All right, this is our scenario PBR with ACL. Here, as you can see, we have this router 1, router 2, router 3, and router 4, and also we should configure EIGRP AS65000. The bandwidth of the higher pass is 2 megabit per second and bandwidth of lower pass is 1 megabit per second. I want to send traffic of VPC1 to the VPC3 with normal forwarding, means with the for example routing table, but the traffic of PC2 to PC3 should be sent from the router 1 to the router 3. As you can see here, we have lower bandwidth between the router 1 and router 3, and also router 3 and router